In this video, we're going to talk about independent events and how to do calculations using the multiplication rule when events are independent. So first we should define what we mean by independence. So technical definition is two events A and B are independent if knowing the outcome of one does not affect the probability of the other. And we need to use that technical definition to be most accurate in most cases. You can find other definitions online which say things like the events don't affect each other, but in some cases that doesn't really work. This is the definition to refer back to if you're not sure. So independent events, things like die rolls, we assume they're independent because knowing the outcome of one die has no bearing on what you would get on the other die. Same with coin flips. If you flip two coins and one is heads, the other still has a 50-50 chance of being heads or tails. In fact, most random outcomes, anything that's generated randomly or selected randomly, you just assume is independent because there's no reason why it wouldn't be. That's how randomness works. A couple examples of events that aren't independent. Suppose you have this event where there's a giant earthquake in Portland, and there's another event with my dying tomorrow. So both of these could happen. They're very, very low probability. But if there's a giant earthquake in Portland, the probability of my dying tomorrow goes up a lot. It might still be low, but this goes up if this one happens. Same thing here. Having over $1 million and being over 65 years old are not independent because your probability of having over $1 million goes way up if you are over 65. Well, maybe not you specifically, but for any person in the country at random, you're more likely to accumulate wealth as you go older. So there's not like a direct relationship between the two. It's just about the probability relationship. In going back to video games, we assume that video game outcomes are independent. So a little bit of notation here, just to shorten things. You can say H equals the attack hits the enemy, and M equals the attack misses the enemy. That's pretty easy. And then the notation, you'd say P of H, which is read the probability of H, or the probability of a hit, we say is 0.67 or 67%. Similarly, the probability of a miss is 0.33. But just watch out, a lot of people get the notation a little mixed up. You don't write P of 0.67. That would read the probability of 0.67. That is nonsense. That doesn't mean anything. The probability of hitting is 67%, is a complete English sentence that this notation refers to. So we have this important thing called the multiplication rule. If A and B are independent, which we often assume for random outcomes, then the probability of A and B, so A and B both happen, is you just multiply those probabilities separately. So if we just look at one example from a video game, if you attack an enemy once, there are only two things that can happen. You can either hit the enemy or miss the enemy. And we've already established what the probability of those are. But then we can make it more complicated, and we can say, okay, if you have two attacks on an enemy, what's the probability you hit with both of the attacks? So that's the probability of a hit and a hit. So instead of A and B, it's H and H. So to calculate that, we do probability of H times probability of H. So we know the probability of H is 0.67. So to calculate this, we just do equals 0.67 times 0.67, like that. And we get 0.4489. So a little over 50% chance of hitting with both attacks. Similarly, you could hit with the first one and miss with the second, which we could calculate. Probability of H and M is probability of H times probability of M. So to do that, we just do equals 0.67 times 0.33, and we work out to 22.11%. Now, the same thing could happen in the other order. Instead of a hit and a miss, we could get a miss and a hit. But the same rule applies. We just multiply the probabilities of each of those, 0.33 times 0.67, and we get the same thing. And that happens a lot in probability, is we can get the same numbers for the outcomes, but the outcomes themselves are different. You know, there's an order here. A hit and a miss is just fundamentally different than a miss and a hit. So for our last one, the probability of a miss and a miss is probability of M and M is probability of M times probability of M. So we just put in the 0.33 times 0.33 like so, and we get 0.1089. So there's about an 11% chance you would miss twice in a row, which is not very likely, but if you play enough games, then you know that that happens, it seems like sometimes a lot. And now to check, now these are the only 4 outcomes. We basically listed every possibility of hits and misses for two attacks. So if you add all these up, if I select them, I can see Excel will automatically count. The sum down here is 1. So total probability is 100%. Now for 3 attacks, I've listed 4 of the outcomes here, but there's actually going to be 8 total outcomes. And I've just listed 4 of them to do in this video, but it works the same way. If you want to know the probability you hit and hit and hit, you know, it's not 2 events anymore like this rule, but it's the same idea as you just multiply the probabilities. So you do 0.67 times 0.67 times 0.67, like so, you get about 30%. HHM would be 2 hits in a row, then a miss, so it would be 0.67 times 0.67 times 0.33, get about 15%. Similarly, HMH, you do 0.67 times 0.33 times 0.67, and unsurprisingly, you get the same thing you had above because you're multiplying the same numbers just in a different order. So it matters when you miss in terms of the outcomes, but for the math, the probability of each of those will be the same. So same thing here, 0.33 times 0.67 times 0.67, you get the same thing again. Now there are 4 more outcomes. So what you're going to do as part of the homework or notes or just on your own for fun is list them, find the probability of each. Whatever, the formatting there is weird, but then make sure all the probabilities add up to 1. Just to make sure you've listed them all, there should be 8 total, so when you find them all and calculate all their probabilities, it should add up to 1. That's the multiplication rule for independent events, and have fun using it.